Good morning, students. In the CET problems, the next question is 81. You are given the several capacitors arrangements in the form of a ladder, they call it as whatever it is, infinite series. Sometimes this will be in two ways. One in between gap may be given here, dot 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 indicates that. Like that we have taken this similar arrangement of C1 C2. They may mention it as a C1 C2 like this. This says C1, this is a C2, and again here C1, again C2. That values will be repeatedly comes. Okay, up to infinity can take. In between any number you keep, result should not change. Like the two ways are asking. One is they may give a gap in between, or they may say here they put the gap instead of putting the dotted here, they put dotted here. Infinite series they will call. Okay, like that you have taken the ladder up to infinity. If you take the infinity, any number, large number you are taking, whatever you take it, that result should not change. So what is the resultant between the capacitance between A and B? Resultant you have to find out. Or sometimes they will give what is the capacitance of this C value. Whatever you have taken is parallel to this relation. The resultant is how much? CAB, if you take what you have to take this kind of arrangements is you leave the right side part some portion and you take it as a separate this part. Altogether you take it as a 1 unit. Okay, let us think that capacitance is Cx between P and Q ends. Let us take it as a Cx, I mean some value. Okay, then this is Cx between EAB is nothing but equal to CAB. This Cx altogether is coming in series with 4 and parallel to 2. Capacitor series is C1 C2 by C1 plus C2, parallel is C1 plus C2. So this resultant is coming parallel to 2 microfarads. You take it as CAB calculation. But in that CAB we don't know, Cx we don't know. But this is up to large series. This will be very large such that adding means up to infinite series. If you have taken these branches n number, very large number compulsory, not 2-3 branches. Large number if you have taken, that large quantity will not be affected by adding just 1 unit. In this ladder, adding 1 unit does not affect the result of this Cx. So if you take this up to infinity, Cx is the result capacitance, then Cx series with 4 parallel to 2 is supposed to be equal to CAB, again approximately equal to CAX only, because this only dominates up to infinity, this dominates over this one branch. That is the method you have to calculate for this. Whether same problem will be given for resistors also. Coming to next topics. So here CAB, answer CAB from this equivalent circuit we have to take modified formula. CAB is equals to, this is a C1, this is a C2, that remaining all points is equals to Cx, or if we are given at the end as infinity means C infinity you have to take. So this is nothing but equal to C1 plus this coming series parallel to this. So parallel is addition. This series means the result is C2 Cx by C2 plus Cx. You may get the quadratic expression sometimes, substitution the values. Quadratic expression if you get to solve it. This CAB is again approximately equal to, this again approximately equal to Cx only. So what I get here is C1 plus C2 Cx by C2 plus Cx is approximately equal to again Cx only. Solve this expression with the substitution values. Quadratic equation if you get, no, solve it. Negative roots you will get, no, negative roots don't take, because capacitance and resistors are always positive only. They should not take negative values. C1 is 2, this 2 microfarads. C2 is 4 into Cx by 4 plus Cx is again equal to Cx. Cross multiply this, you will get Cx square and so on, and solve this. Cx equal to how much? Is again equal to CAB equal to approximately equal to, I think you will be getting that answer as 4 microfarads. Check up this step, I am leaving it to you. Solve it for the quadratic equation and you will get the answer for root for it. And in this question, no, in this question what they told is, the last one mentioned is not infinite series, is mentioned last as a C. Last as a C, what you are adding there does not make much difference actually. That is nothing at parallel coming to this. So we are getting this result is nothing but equal to this only. You have to find out the last C is also equal to 4 microfarads. You have to get. That makes no difference, because infinite series given means not much difference. Whatever parallel is there, that you can take parallel. Next question number 82 is the concept related conductor connected to the earth, what happens to the charges? This is, sorry, 1 minute, in the previous problem it is nothing but equal to C. Connected, makes no difference. In reverse you can take it also. This all you take it as a infinite series. This is, you can take it as a CX or CAB. Parallel to sys4 series with this, and again this is not 4, I think, sorry, 4 2 4 2 4 2. These are 2 microfarads, and to this. I repeat once again, I did it from left to right side. No, you can take in reverse also. If you are asking to find out this right side part, you can take this whole thing as a CX. That means this CX is CAB, is nothing but equal to CX, and parallel to this 2 and series with the 4, and then this is nothing but equal to C resultant. You can find out again CAB equal to how much. Result will be the same as before you will get. Next, next question is, in case if you take a conductor, any conductor having charges connected to the earth. Earth is neutral, always act as a positive and negative both the cases. If the electrons are, if the positive charged body is there, means it will try to be neutral, and whether it is charged or not. Any conductor connected to the earth has the zero potential. Potential of the earth is 0, so object potential is also 0. Maybe having charge also. Okay, but without connecting to the earth, if the positive charge is there, positive potential, negative charge is there, negative potential. But if the charge is there also, if you connect to the earth, no, take it as potential as 0 only. Next is, that means by induction methods. Next is, if the negative positive charge is there, no, electron will flow from earth to the body to make it neutral. And negative, if there is negative charge, no, electrons will flow from body to earth to make it neutral. So depending on that neutralization, what direction charges are flowing. In this question number 82, when bodies are connected to earth, electrons from the earth flow to the body. Electrons are flowing from earth to the body. So body must be having what kind of charges is positive charges. Next question 83, effective capacitance between A and B in the figure shown how much? A and B, you have to check up whether that is a balanced bridge or not. You will be given balanced only. Most of the problems you will be given only balanced problems. Up to Neet also. JEE advanced only may be given unbalanced, but otherwise you will be given all the problems, other exams balanced bridges. Sorry, 83. Find the capacitance between A and B in the figure. Between A comma B. Three, 6, 4, 8. Here it is 3. This is 6, 4, 8. In the middle 2. Effective capacity A and B you have to find out. All are in microfarads. Not mentioned, please. It's a diagram. It is missing. This units take it as microfarads. Find capacitance between A and B. First, you have to check up whether it is balanced. For balanced condition, what we have is P by Q equal to R by S. So if this capacitance is P, Q, R, S, or you can take this ratio, numerator ratio, denominator ratio same. 3 by 4 it is. It is 6 by 8. 6 by 8 is again 3 by 4. So it is a balanced bridge. When it is balanced bridge, you can remove this point diagram. Central capacitance, just remove it. Removing does not mean that making 0. Both cases are different. Making 0 means what? Short circuiting it. So that problem also may be given. You will be given multiple capacitors arrangements, but if they put one line like this, the diagram, circuit diagram, one line they kept means charges don't go this to the capacitors. When they are not going, you all are equal to removing only. Just directly you have to take this diagram like this. Remove all the capacitors, resistors, whatever devices are there. They are all removed. Current don't go cross this zero resistance path, short circuit path. So in this case, Here condition is that potential at this point equal to potential at this point. Potential at this both places equal. That means what? The capacitor can be removed, completely removed. Don't make it a short circuit. If a short circuit is there, then this will not be there. These two. You have to consider only this part. You should not consider these two capacitors if this is a short circuit. Don't short circuit. You have to remove this part. What is this? I will take it is PQRS. CX I will take. CX is removed. It is balanced bridge. Cx equal to 2 microfarads removed. If remove, the resultant becomes only like this. This capacitor will be there in series with this 3, 6, and this is 4, and this is 8. So these two are in series. Series capacitance 3 into 6 by 3 plus 6. So this part becomes equal to 3 into 6 by 3 plus 6, which is 18 by, this is 18 by 9, 2. This is 2 microfarads. This part 4 into 8 by 4 plus 8, which is 4 into 8 by 4 plus 8 is 12. 4 3s are, which is 8 by 3. 8 by 3 coming parallel to 2. So resultant becomes is here, final result, you take this as equal to, this top capacitance is 2 microfarads, bottom capacitance is 8 by 3 microfarads. This is A and B. You must be able to work out only in the diagram only, this rough work only, no need to take multiple diagrams in the competitive exams, spacing, saving the time. So CAB, now they are parallel means just addition, 2 plus 8 by 3, which is equals to 6 plus 8 by 3, it is 14 by 3 microfarads is the answer. Next 85. Electron is accelerated through the potential difference of 45.5 volts. Find the velocity acquired in meter per second. It is an electron accelerated in or with potential difference of 40.5 volts. Electron is accelerated in the potential difference of through the potential difference of 45.5 volts. Find the velocity acquired. Find the final velocity or velocity acquired. Imagining that initial velocity is 0, you have to take. Gained. Take as starting, not mentioned, no, starting from rest you have to take. Work done in the electric field by the potential, work W equal to charge into potential difference. Charge you are moving into potential difference. Delta V is given as 45.5 volts. You can take it simply as a Q into V naught also we can take, but it is not a single point. Potential difference it is 2 points we are taking, or 1 point can be infinity you are taken also. So single you are taken means 1 point infinity. You can take this V naught also we can take instead of delta V, that is left to your choice. Delta V is 45.5 volts potential difference, and charge you are moving is E, that is 1.6 in 10 to the power of minus 19 coulombs. Mass equal to 9.1 into, or 9 you can take approximately minus 31 kg. This is for electron. So what done is nothing but equal to charge into potential is also equal to kinetic energy, that is half change in kinetic energy, which is equals to half mv square. Initially half, if we change is asked, no, difference you have to take, half mv square minus half mu square you have to take. But if they ask it is only final velocity, means they must give initial velocity or take it as a 0. Let us take u equal to 0, that is initial velocity. Then final velocity equal to how much? If they give initial velocity, this becomes half mv square minus half mu square, change in kinetic energy it is. So substituting the values here, this E into V. E is 1.6 into 10 to the power of minus 19 into potential difference 45.5. E is supposed to be equal to half into m into, 1 minute I will mention the symbol form first, E into delta V equal to half into m into V square. And E by m, if the specific charge, if you remember, no, it will be more simplified for us, no need to work out that. Okay, specific charge of the electron is 1.76 into 1.76 into 10 to the power of 11 coulomb per kg. You remember that value means E by m directly can substitute 10 to the power of 11 coulomb per kg. Gyromagnetic ratio we got it as 10 to the power of 10 by 2, half of the specific charge. So you can easily calculate the velocities. Velocity, final velocity V is equals to 2 into E into delta V by m under root, which is equals to under root of 2 into 1.6 10 to the power of minus 19 into 45.5 by mass is 9.1 or 9 only you can take into 10 to the power of minus 31 kg. This velocity turn out to be, you can calculate that. You take approximately this, take it as a 9 only. You can 3 times you can divide that and you will get the answer for this 4 into 10 to the power of 6. You check up the calculations. Okay, 1 minute. If you take 9.1, I directly cancelling here. 2 into 45.5, 91 it will be, 91. So directly cancelling 9.1 is okay, cancelling. So left out is only 1.6, 31. 16 root 16 is 4 only. So you will get as a 4. Decimal you modify, minus 19, 1 decimal is minus 20. Minus 20, this 31 take it to the numerator. Okay, and root you get. 12 under root is 6, 12 root is 6, so you can get the meter per second. So 9.1 only you take for the mass of the electron. Next 87th, what is the work done in carrying a charge q around a circle of radius r? This is a simple question, concept question, and will be asked multiple times. In theory also can be asked. Work done in carrying a charge q once around a circle of radius r with a charge q at the center is, one charge is rotated around the other charge, work done is always 0. Okay, one charge is kept here and center, and you are taking the another charge q rotated in a circular path. So at a given distance r, what is constant is V is constant. At this distance r, V is constant, means equipotential surface, imaginary equipotential surface you get. Whenever the potential is same, compulsory work done means potential difference is required. At the same distance, potential is same everywhere, work done is 0. So work done is 0, one method. Other method you can say that electric field is perpendicular to the displacement you are taking. Moving is like this. So electric field is perpendicular, plus q means away, minus q means towards, so whatever it is 90 degrees. So work done is equals to force into displacement into sin theta, f dx sin theta. So dx perpendicular movement is always dx perpendicular to the electric field. Force acting in the direction of electric field, displacement is perpendicular. So work is nothing but equal to f into distance into cos theta. Theta is 90 degrees here, cos 90 is 0, work done is 0. Like that you can say, or you can say at a given distance potential is constant. Work done requires always a potential difference, not a same constant potential. So answer is 0 place. Answer just write on the side, work equal to 0 you write, because that is equipotential surface. So fourth option, it is none of these, but mention that as mention the reason side. W equal to 0 because it is it forms or it is on equipotential surface, or you can write V equal to constant, you can write instead. This that 88th similar problem we already worked out. You have to go through these problems. Next, question number 90. See, this capacitance after introducing dielectric, before dielectric, or sometimes they will ask you work done to, what is the work done to remove the dielectric. In such case, what you do? For example, you are asked, you are given the capacitor with the dielectric of constant K. Attraction will be there due to the induced unlike charges on the capacitor, capacitor plates and dielectric. Plus means minus. This is a polarized. Plus means minus. Plus minus. Here minus with respect to the plates. Plus polarized, this is polarized. Attraction will be there. So if you want to take it out, work need to be done. What is the work done? They will ask you. What you have to do is, without dielectric, what is the energy of the capacitor? With the dielectric, what is the energy of the capacitor? Difference is nothing but equal to work done. You have to take it up. Difference of the two energies is work done. With the dielectric, dielectric in the capacitor, work done is that energy equal to half CV square with C medium you have to take, or Q square by C you have to take. Depending on the battery is connected or remote. Battery still there means what? Charges will not be constant, potential will be constant, you have to take it up. If the battery is not there, no, then capacitance charges will be constant. That formula, which is constant, that formula you have to use. Constant means if Q square by 2C you can take, if the Q is constant. If the battery is there means what? V constant, so V half CV square you take is better. So difference of the two energies is nothing but equal to work done to remove the dielectric you have to take. But in case you are given, in this case, capacitance changes only given. Before putting dielectric is capacitance different, afterwards different. What is the percentage change means? Change in value by initial value into 100. But question number 90. A parallel plate air capacitor has a capacitance C. When it is half filled, it is half filled place. Half filled with a dielectric of constant 5. The percentage increase in the capacitance will be how much? But in this actual diagram is required. Please take the diagram for this. Otherwise, they mention half filled in what direction, whether it is a series filling or parallel filling. Both cases are there for us. However it is filled, dielectric is added means always capacitance increases. Partially filling also capacitance increases. Half filled, take it like this. This is a K. But even the other case also may be asked vertically filling. This is a D by 2. This is also D by 2. This is air. Means I will take it as a K1 is equals to 1. I will take this K2 is equals to K we can take. So we are connecting in a series combination. Diagram is not there. Please take the diagram for this question number 90. What is given is parallel plate capacitor is of capacitance C. C is the capacitance with air. Okay. Half filled with dielectric of constant K. K is dielectric constant. And C medium is capacitance with the half filled dielectric. You can also take this partially filled formula. What is the formula for partially filled is? You can also take that formula, also does not matter, you will get the same result. The capacitance with the medium, partially filled is epsilon naught A by D minus T plus T by K. Like that also you can take the relation. But other formula we have in terms of dielectric constant. What is the formula we get is this this dielectrics in series it is. Dielectrics in series formula what you get is D by K series is equals to D1 by K1 plus D2 by K2, but D1 is equals to D2 here. D1 is equals to D2 condition what you get here is K series is equals to 2 into K1 K2 by K1 plus K2. That is the formula we have for series combination. So diagram if you know, dielectrics are in series combination. Dielectrics in series combination, we are taking K1 is 1, that is approximately 1 air, and K2 is K equal to 5 they mentioned. and K1, substitute the values, and you are asked to find out the percentage change in the capacitance. So C medium you have to find out. C medium equal to, this is a K series, resultant K series, into C with air, that is C only. This is with air, we will take it as a C air. Percentage change in capacitance is equals to C medium minus C air by initial value C air into 100%. This is the formula. Similar, almost similar problem we have done before, but this is a partially filled. That was fully filled. This is a partially filled. C medium equal to K series into C air. So we can, this becomes equal to K series into C air. I will take out K series into C air. No, C air you take out common, minus 1 by C air cancels into 100%. K series you have to find out. What is K series? Is equal to 2 into K1 is 1, K2 is 5 by 1 plus 5. 5 by 6 means 5 by 3 it is. This is nothing but equal to 5 by 3 minus 1 into 100%. 5 by 3 minus 1 is 5 minus 3 by 2. 2 by 3 you will get 200 by 3. 200 by 3 is equals to 66.6%. 0.66 or 67% you will get the answer. Okay, I want you to work out in the same problem in the different ways. If they give the diagram, is the extra you try to work out, or it may be coming some other place. What if it is filled like this? K1 is 1, K2 is K, like this it is filled. What about the equivalent capacitance? K parallel it becomes. K parallel is equals to, this is A by 2, this is A by 2, D is same in this case. You will get it as K1 plus K2 by K1 A1 plus K2 A2 by A1 plus A2 resolutions. For this is for the parallel combination, no, parallel dielectrics, no. What you get here is K parallel into equal to K1 A1 plus K2 A2 by A1 plus A2. Area is same here. The resultant becomes equal to K1 plus K2 by 2 it becomes. K1 plus K2 by 2. K1 plus K2 is K1 by 2 means K parallel is equals to 1 plus this K2 is 5 by 2. 5 plus 1 is 6. 6 by 2 is 3 is the K parallel. So C medium is equals to K parallel into C air formula. What is the percentage change in capacitance equal to how much? You just try to work out that. Only 2 minutes are there, so we will work out now on that, or okay, we will work out now. Capacitance is equals to C medium minus C air by C air into 100, K parallel minus 1 into 100. So in both the cases you will get is K series minus 1 or K parallel minus 1 conditions, you please remember that. So this resultant is 3 it is, minus 1 into 100%, which is equals to 200% is the increase. Next question is specific charge. You can easily find out the specific charge. Specific charge is nothing but equal to Q by M plus. The specific charge of the proton is given. What is the specific charge of the alpha particles? Specific charge is nothing but equal to charge by mass. So that ratio please check up. Answers may not coincide, I think answer means with the star. You may get the other answer, you verify that.